Obrigada. I will not speak in Portuguese. I cannot do that in front of a big group. I'm living in Brazil only 3 years now, and it's too much for me. So I will do it in English, sorry. Camila asked me to speak about fire stop. And we will discuss different topics, but one of the most important for me is I hear this morning presentation about collapse of buildings, about fire damage and so on. But do you know that 60% of the deaths of a fire come from smokes? Not from collapse, not from injuries, just from asphyxia. And why is that? And this is what I will try to explain to you. So asphyxia is really one of the most important. One of the reasons is because smokes is going much quicker than fire. Smokes can go at a speed of 2 meters per second. There are plenty of analysis which shows that. So we have 62% of the deaths which come from asphyxia. More than 44% of the people who die were not in the room where the fire starts, which means that the smokes go from one room to the other. And so the speak I told you. And in fire condition, you also need to realize that smokes create like fog. You do not see anything. Okay? In addition to that, we know that we have a fire which starts every 7 seconds all over the world. So a lot of fire, and this really creates a lot of damage. In general, of course, except the example we have seen this morning, the structure of the building is designed in accordance to fire. Compartmentation is here. But everybody forgets when there is a fire stop wall that after in fire stop penetration, when we speak about fire stop product in LT, it's only to close penetrations. Okay? And here you have some few examples where there were some fire. It's not exactly the same because this is an international presentation, so it's not coming from Brazil, but I'm sure I could find the same example in Brazil. The first one was a short circuit in the 21st floor, and there were a complete lack of fire protection, building collapse. The second one was during a site work for the welding, and again, a lack of fire protection, and the building not collapse, but has to be rebuilt. And the third one is a fire also. It's an example of fire. But it's an example of fire where the fire protection was completely done correctly, including fire protection for penetrations. And as you can see, 0 deaths, really limited consequence just on the room where the fire was. So it's fire protection is a mixture of plenty of things, but openings is something which is important. If we go to regulation, I will not be the one who will teach you about regulation in Brazil. You know it much better than me, but there are a few things which we can say together, because it's the same all over the world. It's the same in my country, in France, in Europe, in US, in Brazil. It's the same everywhere. Fire protection is crucial. It's a crucial piece of building engineering. And when we say fire protection, it's active and passive protection. I hear this morning about sprinkler, about I've seen some hose, and this is active protection. But passive protection is also very important to make sure that the fire stays in the place where it starts. And there is also something which I like to remind. I don't know who you are. Camilla told me that there are some constructors, some engineers, maybe some architects, some firemen. Everybody has a role in fire protection. It's not reserved to the one who will install. It's also the role of the architect to schedule very upstream when we start the building the building design, going to the specifiers, the design office, who should specify it, and not just say fire protection should be there, because this means nothing, and the constructor after will not know which product he should use. So the specifier should really specify, and then of course the constructor should install the correct product. And if we have the full chain of responsibility fulfilled, we are sure that at the end we arrive to the example, remind, one building, a fire, no damage. And this is what we all want. Compartmentation, despite the fact that everybody thinks it's to protect the building, the main reason of compartmentation is to protect the fireman and the person who are inside the building to escape. So the person who are inside the building to escape, the fireman to enter to help those guys to escape. This is the ultimate goal. We want 0 deaths. Of course, if on top we can also protect the building, it's good. But the main reason is really, so it's the reason why we say, for example, that a firewall should remain 2 hours. After 2 hours, we think that the people, or when I say we, it's the one who prepare regulation thinks that there will be no more people inside. So if the building collapses, it collapses, but at least there is no death. Okay? And so we have horizontal compartmentation. I'm sure you have all seen a building, an hotel, an hospital, where you have fantastic firewall, super fire stop doors, and just on top, a nice hall with pipes and cables, not closed. So what do you think is the efficiency of the wall and the door if just above there is a big hole with nothing to close it? Nada. Forget it. Okay? The same for vertical compartmentation. The vertical compartmentation is, of course, for the floors, but it's also for the facade. Everybody has seen a tower, sadly, in fire, and we see the fire jumping from outside, from one floor to the other, from outside, because the facade is not protected. Again. And now we arrive to what I'm more used to say, our product. You have plenty of different things in a fire. Is there a laser? Yes. So, doors, walls, floor, windows, okay, we all know. But here you see there is a cable. Here there is a pipe. Here you have 2 pipes. Here you have a cable trace. All these openings, if they are in a fire stop wall or a fire stop floor, they should be closed. I put this just as a reminder, but again, you know much better than me the regulation of fire stop in Brazil. All what I know is what Camilla told me during webinars. I'm listening to the webinars she's doing, and I know that there is plenty of regulation. I know that there are some federal regulation, state regulation, local regulation, standards, fireman documentation. You have plenty of documents. Now the main thing is to make it endorse, to make it used, to make it live. So I will not describe this. It's your role, it's not mine. And I will go to approvals, because there is several systems all over the world, including in Brazil, which are different. When we speak about approvals, it's a product which has proven that he has some fire resistance, in our case, with a third party. So it's not the manufacturer itself which says, my product is good, because we all can say this. It's someone else. So we have different systems. And here in Brazil, it's the third one, but sometimes we use the two first. The first system is a US system. So you have a certification which is done by UL, and they follow two different ratings, the F rating and the T rating. So the F rating is obvious. It's a time where the fire, the flames, will not go from one side to the other. But what is the most difficult to achieve for our product is the second one, is the T rating. The T rating is the time where the smokes will not go from one room to the other. And if you remember what I told you at the very beginning, 62% of the deaths come from asphyxia. So we need to also make sure that the fire do not jump, but the smoke stays in the room. So this is what means T rating in US. In Europe, it's a little bit different terms, but at the end it's the same. We measure exactly the same. Maybe there is one small test which is different, but at the end it's exactly the same. We measure the time where the fire do not go from one room to the other, and we measure the time where the smoke stays, and we also measure the time where the temperature on the other side of the fire do not increase of more than 180 degrees. Because if you have a too high temperature on the other room, even if the fire do not jump, there can be some auto-ignition because it's too hot. And if it's too hot, you have some product which can auto-ignite. I don't know if you have seen some video, but I have seen some which are very impressive, where you see, just by heat, you see auto-ignition. And the third system, which I put it here, it's the Brazilian system. But at the end, it's not exactly the same. Because in Brazil, we have only a test standard. We do not have an approvals. We do not have a paper which says this product have this performance with acceptance criteria. So what Camila and the team do in Brazil is really to combine tests done in Brazil, of course, because we are in Brazil, with approvals which we have from other countries, from Europe or from US, depending on the case, depending on the product. Because when you look to fire resistance, you cannot imagine the number of parameters. When we create a fire stop test, you cannot imagine the number of different combinations we could have. Because sometimes, so, you have to take care, of course, about the base material. Is it concrete? Is it masonry? Is it wood? All those kind of materials exist in the market. Then we need to take care about the distance, because if you have two pipes which are close to each other, for sure the protection will be different than if you have, I don't know, 10 centimeters between the pipes. So you imagine the number of combinations we could have. Because the penetration element is important. A PE pipe will not burn like a PVC pipe, will not burn like a metallic pipe. A cable, there are so many cables, they do not burn the same. And we always need to have a product which will close the gap. If the pipe melts, we need to make sure that the opening will be closed immediately. So this is exactly what we do in approvals. We do series of tests, and then based on acceptance criteria, the third party tell us, okay, you can use this product with this characteristic, with this fire resistance for all this range. Because if we have to test every single application, you imagine, cost would be, as a lab, would love us, but probably it will be very, very expensive. So when you see a US approval, it's normally done by UL. We have two standards in US which are important to know. One is for penetration element, and the other one is for joints. When you have two slabs of concrete in a parking, for example, I remember one parking where I finally decided not to stay and to leave my car because the space between the slab was something like that, 2 centimeters, completely open. I tell you, it was not fireproofed. And you have one sheet of paper per type of application. So you always have the same way of presenting. So you have the information here, the ratings and so on, the sketch on how it should be installed, because sometimes, let's take the example of a collar. Sometimes you put one collar behind. Sometimes, due to the size, you need one collar behind and one on top because it's a very big pipe, and just one collar will not be enough to close the gap. Sometimes you need to have a sealant around a product, sometimes not. So all these kind of details, which I don't know by heart, because it's impossible to remember everything, but I know where to find it. It's in this kind of documents. So in US, it's one sheet of paper per type of application. Where in Europe, it's completely different. In Europe, we have one approval for one product, which can be, and I think when I was still in France, the most important one was for the endless collar. It was a document of 120 pages. Because you have all the application tested in one document. Everything is in one document. And then you need to be very careful when you choose your application. So you need to really study the type of materials, the positions, the penetration elements, the dimensions. So it's really, I would not say a science, but nearly a science. And of course, if you do not take the good product, the result may be not the one you expect. And in Brazil, as I told you, in accordance with the IT 09, there is a test which is described, which is done by IPT, at least, maybe there are some others, but we work with IPT. And this curve, I know it, because it's exactly the same as the ISO curve, the US curve, the European curve. It's always the same curve, which shows the increase of temperature in the furnace. But again, when you do a test in Brazil, you just have a test report of what you have tested. You do not have any approvals because it does not exist. Maybe in future, if there are some work done in terms of preparing the framework, it can be done, but today it does not exist. Nowhere in Latin America. I'm working for all Latin America and it does not exist in Latin America. And you have also some, I took this example because this one I really like it. I already say it. by the way. You have one standard which speaks about how to design a residential building. And in this standard, it really says that there are some responsibility for everybody. The architect, the owner, the design office, the contractor, the specifier, and of course the fire brigade who do the inspection. So it's everybody who is concerned by fire protection. It's not only the one who install. Again, I insist because I've seen so many design offices who told me, oh, no, this is not for me. This is for the job site. No, it's for everybody. Now let's go to the product. So I did not speak at all about ILT since the beginning of my presentation. Of course, for the product, it's a picture of our product. I do not do a picture of our competition. Sorry. So, active protection, passive protection. Passive protection, you have different types of elements, which are normally grouped in 4 groups. So you have the construction element, of course, the wall, the concrete, the masonry, which are fireproofed. You have some service elements like doors, like windows, like glass. I've seen a promotion of a fire stop glass at the entry of the auditorium. These are elements for building. You have dampers, which are very important to extract the smoke. And then you have our fire stop product. Product which are, again, to close the openings. And this is a small sketch which shows you all the different types of penetration which we can close. And there are so many. You cannot imagine how many cables or pipes are running in the hidden part of a building. No, you can, for sure. It's your job. But we always forget them. At the very end, the fire protection of those small elements are forgotten. And this should be the complete contrary. This should be studied at the very beginning. Because sometimes if you organize the pipe better, the fire stop system will cost you half of the price. Because you are in a range of application where you can use only one jacket or one color. And if you put 2 big cable bundles, here you need 2, and of course the price will be doubled. Very basic. So when we say that fire protection is expensive, it's expensive when you do it at the very end, because you have no other choice, because the fireman is here and tell you, no, you cannot open your building, because you miss that. At this moment, yes, it will cost a lot. But if you have designed it probably 1 or 2 years before, the cost will be peanuts compared to the cost of the building. In ILT, we also take very seriously the safety of our product and the quality of our product. So we have huge research and development, and we have our own furnace. We have 2 places in the world where we can do some fire tests for our product. We have one in Kaufering in Germany, which is where we have our development system, our development for European products. And we have one in Dallas, where we do our development for the US product. And in both cases, we have a furnace, and I've seen myself some fire stop tests done there, which are really impressive. I had once, and this is why it's important to test, I had once the experience to see a fire stop test which failed. And this is much more impressive than a fire stop which runs. Because if it's running, you see nothing. You are in front of the furnace and you just wait because nothing happened. But when it failed, I tell you, when you see the speed where it failed and where you have to evacuate the lab, this happened to me once. And when I came back home on the evening, I was still with a headache, and my husband asked me, what happened? Oh, just I smell smoke. I think I had the feeling to be smoke from... It was really awful. And if you have the opportunity to go to see a fire stop test in IPT or outside of Brazil, go. Because I tell you, to be aware of the danger, this is the best. For me, this was really helpful to understand the danger of fire. And we also can do engineering judgment, because I told you, we cannot test everything. It's impossible. The architects have a lot of creativity. The design office have a lot of creativity, and we cannot test everything. It's just impossible. So sometimes we can, because we know that in Poland or in Germany there was a test which was done, which is similar. So we can do what we call engineering judgment in some case, in order to avoid to redo a fire stop test. Because of course the ultimate solution is to do a test, but to do a test you need 2 months minimum to organize a test. So this is important for us, and we do job site consulting. If you have any question on job site, we have a team of engineers all over the world who can support and give you some advice. And this is my preferred slide on the presentation. Because when I arrived in ILT, 99, fire stop was just mineral wool and sealant. This was the only product which was existing in ILT. I don't know if you have yourself installed mineral wool and sealant. I do. I forget my gloves. And I tell you, to install mineral wool without gloves, it's a disaster. To install a mortar, you need hours. So we have developed some products which were more easy to use 10 years ago, like foams, sprays, which are easier to use than mortar or coated boards. But still, to install a foam, you need a dispenser. To install a spray, you need a dispenser. So now we are on the next generation of products. The products which are installed by their own. Imagine, this is a cable disc. It's like a sticker. You put it around, you take out the sticker, you put it around the table, glue it on the wall, done. Fireproofed. You do not need anything anymore. It's just there. We have plenty of examples. This one has just been launched in Brazil. It's, how do you call it in Portuguese? Spit sleeve. Okay, so it's the same as in English. The spit sleeve is metallic, contain inside something like socks in intumescent product. So imagine, you twist in one side, it's open, you can pass your cables. You twist it the other side, it's closed, fire stopped. You have to repass a cable? No problem. You twist, you pass your cable, you twist again, it's done. You do not need any more mineral wools, sealant, dispenser. All this stuff are out of age. I should not say this because I'm of the old generation now, but I really love this product where you are sure you will not do any mistake. Because you cannot do a mistake. It's just you twist, you pass your cable, you twist on the other side. I could speak about those products for hours, but probably it's not a good time for doing it now. And if you schedule it in advance, this is to avoid these kind of examples. Because here I tell you, a fire with this kind of examples, the building will not survive. Look at the gaps. Look at the number of cables. How do you want, with such a concentration of cables, how do you want to avoid the smokes to go inside, between the cables, and arrive on the other side? It's impossible. Probably this should have been cut in two, with two different openings. And again, if it's done before, it's possible. Here it's much too late. And of course it will cost a lot of money, because here you need to do a box around with plasterboard or more of, or I would say mineral walls, but it's impossible to solve this case. But you cannot imagine how many times we are called on job sites for such examples. These are pictures which we took ourselves. These are real examples. And another thing which is important, and I can imagine that everybody who has to do audit or inspection of job site cannot say anything against this, is about documentation. How do we remember, how do we prove that the job has been done correctly and that the fire protection is there? How to make sure that we have the correct installation? How to make sure that this is the correct product which has been installed on site? Sometimes you have, in an hospital, you can have thousands of openings. How to make sure that the contractor has put the correct product on opening 1, on opening 2, up to opening 1000? The best way is to document this. And for this, there are some software which exist in the market to document fire protection. So, I will not do more publicity, but if you want to know more, you can just ask Camila. And when you see applications, these are the pictures which I would love to see each time I'm going on job site. These are pictures of applications which are done correctly, with a nice mineral walls coating done correctly. Here you have a fita, you call it? Fita intumescent. Here you have again a mineral wool. Here you see some bricks. Here also you see some bricks. Here you see some plugs. So these are penetrations which are correct, meaning that we all hope that there will be no fire, but if there is one, the fire will not go on the other side and will protect life and the assets. So I have plenty of examples. Here it's, and I have examples all over the world because we have a bank of reference in ILTI. So it can be in buildings, it can be in power station, it can be in industry, it can be everywhere. We have plenty of examples where it's very important. And that's all.